So today we are going to talk about investment decisions or capital budgeting decisions. The learning objectives in this, uh, what are the implications of the net present value and what are the methods of calculating net present value and IRR, and why the investment decisions are important, and the discounting and non-discounting techniques and the criteria of decision. Okay, and we have investment decisions now. What is the nature of investment decisions? Now, generally they are for a long-term purpose. Investment is for long-term. So they are capital in nature. Revenue means for less than 12 months. Beyond 12 months, if you are investing, that's capital expenditure decision or simply investment decision. And the firm's investment decision, it is either for expansion or modernization or acquiring the business of another company or replacing the existing facilities. Okay, so for these purposes, you need money. Okay, you need huge amount of capital outlay. Now, decisions like the changes in the sales distribution also sometimes requires huge amount of capital, and I feel research and development requires huge amount of capital. For example, now these days for the COVID, most of the countries are willing to contribute huge amounts of money on the research and development. It may take a month or 2 months or even a year. Okay, and once the vaccine is developed, the production is nothing. Sometimes uh, to find out the exact vaccine for the coronavirus, COVID, uh, it may, let's say for example, $100 million, and with $100 million you can produce thousands and thousands, maybe lakhs of doses of the same vaccine for years. Okay, so investment in research and development also requires huge amount of capital. I want to say that. Now, in light of that, let us look into the features of investment decision. Number one is for future benefit. You are investing now and you are investing for long-term purpose, and the benefits will not be reaped now but over a period of time and over a series of years. In future you will be reaping, not now. Okay, now let us look at the how significant these investment decisions are. Now, as we have seen, the companies, when they want to expand, okay, for growth of the company, they had to invest, okay, for the expansions. And one thing you should understand is investing for the long term is risky. Okay, it is risky. It is risky for the reason it is irreversible. And it is irreversible at the same time, it is also complex. Why it is complex? The investment decision is complex. You're not sure whether you're going to develop a vaccine after 6 months. After spending this 100 millions also, you're not sure whether you'll be able to come out with an output. It is very uncertain, but still, with a hope that you will come out with a vaccine, you will still invest. And what you have invested, you cannot get back. It is irreversible, right? And there's a huge amount. And because of this is risky. It is risky. It is risky for the reason it is irreversible and it is also complex. Okay, now types of investment decisions. There are two types of classifications. One classification presents us three types: expansion of the existing business, an expansion or developing a new business, or replace the existing plant or modernize the existing one. For modernizing the existing one, for taking over the new business or setting up a new business on your own, or going for the expansion. Okay, you have, let's say, 1,000 units of production capacity, you want to extend it to another 1,000 units. Let's say, this testing kits, COVID testing kits, you have a capacity of 1 lakh units. And if the need grows, so then you may have to go for another 1 lakh, okay, capacity. That's expansion. Okay. Now, the above one is one classification, then the below one is another way of classifying the investment decision. Now, some projects are mutually exclusive. That means, investing in one project has nothing to do with investing in another project. Let's say if L&T has, L&T has two projects, one in Oman and another one is in Hyderabad, metro rail. Okay, I'm talking about, previous one. It is already over. The investment is over. They have spent the money. So if they have two projects, the investment in Hyderabad, okay, the money spending on the project in Hyderabad metro rail has nothing to do with the investment in Oman, okay, in Muscat flyover construction. Okay, they are mutually exclusive. And independent. Okay, now contingent investment. In statistics, you might have come out with these terms. When you're talking about the probability, did you complete statistics probability? May I know from you? Hello? Hello?
Yes, sir.
Hello?
Yes, sir.
Sir.
Did you come across these terms, mutually exclusive and independent investments?
Yes, sir.
Not investments. I just want to know whether you have come
Independent.
across these words, mutually and independent, mutually exclusive and independent. Forget about the investments.
No,
Mutually
no, sir.
exclusive,
No, no,
independent.
sir. No, sir.
Okay. Now, by mistake, I have misled you with my discussion, just a slip of tongue. Let me correct you. Okay. Let me correct myself and present you. Okay. Are you able to hear me?
Yes,
Yes,
sir.
sir.
Yes, sir. You're
Yes,
audible.
sir.
Okay. Okay. Now, you know, uh, the tossing of the coin. If you have 1 rupee coin or
Yes,
2 rupees coin, tossing of that coin, do you
yes,
know?
sir.
Yeah, you
Yes,
might have done it right in the childhood when you're playing. Right. When you toss the
Yes,
coin, there are heads and tails. Okay, head and tail.
yes, sir.
Okay. Now, if the coin appears to be, okay, after you toss it, and if the coin appears to be head, what does it mean? When it is head, there should not be tail. Correct? And if it
Yes,
is tail, there will not be and should not be a head. Okay. Head, it can be head, it can be tail also. Can there be such situation?
no, sir.
No,
Very
happening
rare.
of one event prevents the happening of other event. Okay. Now, in simple words, you're all executives. It doesn't happen with you, but with the regular students, it happens. Okay. In the university culture, whenever there's a misunderstanding, okay, and if there are two party students, students belonging to two parties, now there are no politics in the campus. Uh, Now, official politics are not there, like ABVP, PDSU, and things like that. They're not there. Elections are not there. So earlier elections used to be there, and during those days, when the fight goes on, the situation goes to that extent. It is like this. Now, let me make a statement. If that student comes to the class, I will not be there in the class. And this fellow also challenges. If that student comes, I will not be there in the class. So the presence of one student prevents the presence of another student. If A student joins the class, B will not be there. If B joins the class, A will not be there. That is mutually exclusive. If you invest in this project, you cannot invest in other projects because the money is limited or sufficient enough to invest in this project, and there's no money anymore to invest in other projects. Okay, that's mutually exclusive. Now, independent projects means, investing in one project has nothing to do with the other project investment. That is independent. If that fellow comes or not, what does it matter to me? I will attend the class. That is independent. I have nothing to do with him. Independent. Okay. So contingent investment, the word contingent, that is, emergency. On an emergency basis, if any investment is, there's a sudden fall of a huge crane in a shipyard. Suddenly it collapsed, and that is about 50 crores worth crane. Huge containers are lifted. Today I was looking into the project management PMI's case study, and I was looking into the case of Panama Canal, and in the canal is so big, the huge ships are passing through that, right? And each crane costs millions of dollars. And if that one crane is collapsed, it's a huge investment. And you didn't expect that. And that happened. One ship came and hit the crane, and that crashed. That's a contingent investment. Okay, so let's come back. Mutually exclusive, independent investments, and contingent investments. Is it clear, sir? Other than Shiva,
Yes, sir.
anybody?
The only one for India.
Yeah, if you want to add anything, you are welcome to do so.
Fine, sir.
Is it clear? The mutually exclusive and independent.
Yes, sir.
Yeah, earlier, there was a slightly, I had a slip of tongue, and then I have just clarified it. Okay? Right. Now we'll go to the next. Investment evaluation criteria. What you do is, this is the process. In the process, first you identify the cash flows, then you identify the required rate of return. The required rate of return that we have seen in the first chapter. Okay. Then the opportunity cost of capital, what we call, then apply the decision rule for making the choice. You can accept the project, you can reject the project. Now look at this. This is a project proposal. And this project proposal, when you evaluate, you will come out with a decision whether to go with this project or discard this project. That is what you're going to do now. Yeah. When you are making this decision, you are trying to maximize the wealth of the shareholders and the profitability for the project, and you should be able to identify what are the worthy projects and what are the useless projects, and you will rank the projects. Okay, you will rank the projects. Right, now let's go to the evaluation. These are the techniques available to us: net present value, internal rate of return, profitability index. These are called discounted cash flow techniques. And number two, non-discounted or traditional cash flow techniques. These are traditional techniques of evaluating a particular project. These are traditional techniques. Non-discounted or traditional, and discounted or modern. They're latest. Before these techniques came, people were assessing the projects based on these techniques. Okay. Now payback period. Okay, accounting rate of return. Now, discounted payback period also should come here. Okay, discounted payback period also should come here because discounted cash flow criteria is this, the first one. Net present value. Net present value. Cash flows of the investment project are to be forecasted on realistic assumptions, and you should identify the appropriate discount rate and the present value of cash flows. Okay, present value of cash flow should be calculated using the discount rate or the opportunity cost of capital. Now, this is important. The net present value should be found out by deducting the present value of cash flows from the present value of cash outflows, the present value of investments. Look at this. The present value of investments. Here it is, you're seeing cash flows. I am reading it as investment. The present value of investments, what you're seeing is cash flows. What I'm saying is investment. The present value of investments is deducted from the present value of future cash flows. And if you get a value which is above zero, then the project is viable. Okay, the project is positive. That means your future cash flows are more than your investment. Now, you will understand it more clearly when we take up a problem. Now, let's go to the next step. Even this you don't understand, you get scared. Now, I'll come back to this after we work out the problem. Okay, if I straight away show you the equation, you get scared. I'll go to the problem. Okay, there you feel more comfortable. Yes, this is a problem. Assume that project X costs 2,500 crores now and is expected to generate year-end cash flows of 900 crores at the end of the first year, and at the end of the second year 8,000 crores, at the end of third year 700 crores and 600 crores and 500 crores respectively in the fourth and fifth years. The opportunity cost of the capital, if you assume to be, or if you have identified it to be 10%, this is the discount rate. The opportunity cost of capital, or weighted average cost of capital, or the discount rate, or the identified discount rate is 10%. Okay, this 10%. Now, do you understand, do you recollect what is this 10% or the cost of capital or the required rate of return? Can you recollect? If your rupee gets deteriorated by 10%, if your rupee gets deteriorated by 10%, and if you are investing 1,000 now, after 5 years, what is the value of this 1,000 if it is getting deteriorated by 10% every year at the end of the 5 year? I have taught you discounted technique, compounding and discounting techniques. Money getting multiplied is compounding. Money getting deteriorated is discounting. We discussed about it at the time value of money, okay, in the previous session. Okay, now this is the problem. Okay, now net present value is calculated like this. Now look at this. The value of 900 crores that you receive at the end of the first year gets discounted by this value. Okay, 1 plus I, 1 plus 1 by 1 plus I whole power n. The n is the first year. Okay, 900, actually it is 1 by I'm sorry, fn by, okay, f, or simply f by 1 plus I whole power n, right? Now that f, the future cash flow, I'm replacing with 900 for first year. 900 by 1 plus 0.10. What is this? This 10% discount rate. Okay, if this 900 gets discounted by 10%, the value of this 900 crores is 900 into 909. I'm sorry, 900 into 0.909. Okay, 900 into 0.909. Okay, yeah, it is like this. It is like this. If you go to the PVF present value factor tables, you will be given the years on the left like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. And horizontally, you're given, okay, you're given 1%, 2%, 3%, 5%, no, 4, 5, 6, 7%, and it goes on like this. The percentages are given. What are these percentages? They are discount rates. Okay, they are discount rates. They are opportunity cost of capital. Okay, presented in percentage. Now the present problem says 10%. Under 10% against first year. Against first year under 10%. The value, the factor value is 0.09. 0.09. Okay, what does it mean? At the end of the year, 1 rupee becomes 90 paise point 9 at the end of the year. That is for 1 rupee. For 100 rupees, 90 rupees point 9. For 900 rupees, for 1000 rupees, 900 909 it will be. Okay, for 900 crores, how much it will be? Okay, you will be calculating that amount, right? And similarly, at the end of the second year, 800 crores you're receiving by 1 plus 0.01 plus 0.10. This is 10%. This is 10%, sir. To the power 2. N is 2, that is at the end of the second year. This is the cash flow in the second year, and you discount it with this factor 800 by 1 plus I whole power n. Okay, now same thing, at the against second year. Now against second year under 10%, what is the discount factor? Discount factor is 0.826. 0.826. Now the same thing you do for 700. Okay, under 10% again, but against the third year, the factor is 0.751. Okay, then again do the same for 600. Okay, now this is fourth year. Against fourth year, under 10%, it is 0.683. Okay, now let's go to the fifth year. Against fifth year, under 10%, it is 0.620. 620. Okay, 620. Right. All these values come to 2725. If you multiply 900, yeah, can you please quickly do it? Okay, without wasting time. One person can calculate 900 into 0.909. Another person 800 into 0.826. Another person 700 into 0.751. Can you please calculate quickly and give me the values? Okay, so that we can quickly add it up. And check whether it is 2725 or not.
For 900, 818.1.
First one is
818.1.
818. Yeah, and second one
661.15.
Okay, next. And somebody please add up, please take these values and add up. Yeah, is it 2725? Sir, 2725. Yes. Okay, 2724 also is okay. We have rounded off to 2725. Okay, that's great. So 2725 minus, now look at this. We will come back to the statement. We will come back to the statement. Okay. We made a statement, right? Yeah, look at this. Net present value should be found out by subtracting the present value of the cash outflow, present value of the cash inflow. Subtract the present value of the cash outflow from the present value of the cash inflow. Okay. And let's come here. Let's come here. Now, these are all the present value of cash inflows, the total of the sum of this, and this. All these five are present value of cash inflows. Cash inflows. Now, if you see the absolute figures, 9 plus 8, okay, 17 plus 24 plus 30, 5. 3,500 is the absolute figure. If you count all these 9, 8, 7, 6, 5, it is 3,500. But that 3,500 is brought. Can you mute yourself? There's a bit noise I'm able to hear. If there's a noise, kindly mute yourself. Okay. Yeah. So it is 3,500. That's the absolute figures. That 3,500, we have reduced it to 2,725, which means the value of 3,500 you will be receiving in a span of 5 years. Okay, 900, 800, 700, 600, 500 respectively each year is only 2,725. The worth of those 3,500 is only 2,725 now. Okay, and our statement says subtract, deduct the investment. Okay, the outflow. Look at this. A project X, required 2,500 crores. Okay, that means you have spent this amount, and you will be spending this amount. If you spend this amount and you're getting these cash inflows, okay, this is your outflow and these are your inflows. The difference is 225, which is net present value. The present value of cash inflows minus the present value of cash outflows gives you the net present value. So here, this project in a span of 5 years gives you 225 crores. So therefore, you can go with the project. Okay, and this is subject to ceteris paribus. Other things remain constant. Okay, if all the other things remain constant, you can go with this project. You had to assess the risk factors. It's like what happened. The GMR has invested a huge amount in Maldives airport, Mali. Okay, in the Mali. Excuse me. And after the government changed, they refused to allow them to continue the project and ask them to leave the country. That's a risk factor, political risk. So you have to look into all those things, not just the NPV. So many other things, other factors you have to look into. Now, accept and reject criteria. Okay, do we accept this project? We accept because it is positive, but subject to other conditions. Okay. Now, accept the project when the NPV is positive and reject the project when the NPV is less than 0 or negative. And if it is zero, if your cash inflows are equal to cash outflows, then you have to think what are the other things that will motivate you to continue with the project. Okay, the first 5 years it may be 0, after that it may be growing. Now look at this, the Hyderabad airport also is like that. Hyderabad Rajiv Gandhi International Airport also, for first 5 years it was in loss. Okay, negative, and after that only it started reaping some excess surplus, that is profit, right? So there are many other things that you have to look into, right? Okay, now let's come back and look at why the NPV is important. Look into this. Why it is important? Yeah, this is the most widely used project investment decision. Okay, because it considers the deteriorating value of money. Okay, the behavior of money is that its value goes down as the time passes by. Okay, so because it's a discounting technique, it is important. And not only that, every year on yearly basis, whenever the cash flow is occurring, at the time only it is discounted. Okay, not for the okay. Right. Can we continue, please?
Yes, sir.
Yeah. Immediately, you can come out easily. What is the, amount left over, the surplus amount available after we recover whatever we have invested in the project. In this technique, it is clearly visible. So therefore, most of the project managers use this NPV. Okay. Now, yeah, for these reasons, there's a time value concept that is discounting is used, and this is the true measure of profitability. The answers why it is important. These are the reasons why it is important. Okay, and the limitations. How do you estimate cash flows? What is the scientific way of estimating your cash flows? And what rate should you decide? You said 10%. What is the basis? Okay, why 10% only? Why not 12%? Okay, and generally projects are mutually exclusive. So therefore, ranking the project is not that easy. Okay, so these are some of the demerits of this techniques. Next one is internal rate of return. Look at this, sir. You've seen the net present value, right? Okay, you've seen the net present value. It is, I'll just tell you in simple words. Yeah, look at this. Here you are given the rate 10%. You're given the rate. Now, in the case of internal rate of return, sometimes the project managers, they may be interested in what is the rate of return I will be getting. What is the rate of return I'll be getting? Okay, sometimes when you ask or trying to borrow money, your concern is what is the rate of interest, and the lender's concern also is what is the rate of interest that I can get. Okay, now what is that rate? What is that rate? Internal rate, or the opportunity, the rate of the cost of capital, opportunity cost of capital. What is that rate? Look at this. Now, here you got a positive figure, right? 225. Why 225? Your cash outflows are more than the cash inflows. So cash inflows are more than the cash outflows. That is, you have a surplus of 225. The cash inflows have an excess of 225 crores over and above your investment. Okay. Now, come to a situation where, imagine a situation where this becomes zero. This becomes zero. How this becomes zero? This becomes zero when this discount rate is altered. Instead of 10%, if you are making it 12%, this amount comes down. If you go on increasing this rate, this cash inflows, the present value of cash inflows, the present value of cash inflows or present value of cash flows, they will come down. Now it is 2725. If you are applying 12%, it may come to 2500. Okay, so internal rate of return is what is the rate at which the present value of cash inflows and present value of cash outflows become equal so that the NPV is zero. What is the rate? Again, I'm coming. What is the rate at which the present value of cash inflows and the present value of cash outflows become equal, thereby the net present value is zero? Okay, that is the rate. Now come back. Look at this. The internal rate of return is that rate which equates the investment with the present value of cash inflows received after a particular period of time. Okay, a particular period of time. Now this is cash inflow for first year, cash inflow for second, third year, and till the nth year. Okay, and the total of the cash flows is this. The sum of all the cash flows is this. Present value of cash flows. Why I'm saying present value of cash inflows? They're divided with the discount factor 1 plus I whole power n, or 1 plus r. Author to author, they keep changing. I said 1 plus I, and this author says 1 plus r. This is the rate. Okay. Okay, 1 plus I whole power n, right? Minus CO is equal to 0. What is the rate at which these two, what is the rate? What is the rate at which the total value of the cash inflows, the present value of cash inflows, equal with the present value of cash outflows, so that the NPV is 0. Okay, that is the internal rate of return. Internal rate of return is that rate which equates the present value of cash inflows with the present value of cash outflows. It is that rate where NPV is 0. It is that rate where NPV is 0. Where NPV is 0, when the present value of inflows and outflows are equal, NPV is 0. Okay, so that is the internal rate of return. Yeah. No, I'm not going with some of the equations and the descriptions, because you may get confused. Okay. So please try to yeah. focus on the problems. It is easy for you if you take a problem and try to understand. Now, I'll just give a pause here as you go through the problem and others can raise your doubts and questions. Okay? Just 2 minutes, I'm giving a pause. Please raise your doubts as you read the problem. Yeah, let us assume that an investment would cost 20,000 and provide annual cash inflows of 5430 for 6 years. Okay, 5430 for 6 years, right? Now, it's an annuity. Annual cash flow means, it's consistently, it is giving the same amount. Okay, 5430 is the same amount, all 6 years. So what you can do is, you can go to the annuity formula, or you can go to PVAF table. PVAF table. Okay, go to PVAF table, not PVF table. Because PVF table previously it is 900, 800, 700, 600. Now this is not like that. It is not changing every year. But in this case, every year you're receiving the same amount. Okay, 5430. Okay, this is annuity, right? This table that you have to refer is different. The previous one is PVF and this is PVAF. A is added, sir. Before F, A is added. A means annuity. Okay, annual cash flow. Annual means every year you receive the same amount, 5430. Okay, right. Now what you have to do is, in that table you will come across, okay, years as usual. Then you will get the percentages, right? 1 2 3 4 5 like this. So yeah, now you don't know the rate. Here what you're doing is you're trying to calculate the rate. Okay, you're trying to calculate the rate, and you know the year. 6 year, 0 1 2 3 4 5 6. 6th year you know, but which rate you don't know. So what you have to do is, the total amount the total investment required is 20,000, and every year for 6 years you're receiving this amount. So 20,000 by 5430 annual cash flow, you will get 3.683. 3.683. Take this amount, 3.683, against 6th year. Look at this, sir. These are the percentages and these are the years. 0, 1, 2, 3, 4, 5, 6. Again 6th year, come slowly under the percentages. These are the percentages. Under the percentages, okay, slowly, okay, till you get a figure which is nearer to 3.683. Sometimes it may be 3.52, or sometimes it may be 3.42, or sometimes it may be 3.7. Anything that is nearer to 3.683 against 6th year, you keep coming and coming and coming. Okay, and you will identify some value which is very close to this calculated value and go straight above that value and find out the rate. In the previous problem, rate is given and you're calculating the value. Now the value, with the help of this value, you're trying to trace the rate. Okay, this is the rate, internal rate of return, internal rate of return, internal rate of return. Look at this, sir. This is the rate of it. Let's say if it is 12%, this 12% is the internal rate of return. The internal rate of return of this project is 12%. How did he get it? You have got the cash investment, okay, the project investment, and this project gives every year this annuity. So total investment by the annuity gives you a figure, a value, okay, a factor, and this factor you try to locate from the PVAF table. Against sixth year, under you go on searching for the nearest value, and again above that value you just go straight above, and that is the rate. That is the rate. What rate? Internal rate of return. Internal rate of return. Internal rate of return. Okay. Clear? Yeah. NPV, NPV, and IRR. Look at this. The cash flow is 20,000, right? This is the investment initially. Okay, actually this is zero, sir. This is zero. This is mistake. This is 0 year. Okay, this is 0 year, and this is first year, and this is second, third, fourth, fifth, sixth. Okay, this is a mistake, right? I think I should not be confusing you too much. We'll skip this, but I'll just try to quickly finish it off. Yeah, if this is the amount invested and these are the cash inflows for 6 years, 1, 2, 3, 4, 5, 6 years, right? And if this is the discount rate, okay, and wherever the NPV is 0, that is the internal rate of return. That is, this is internal rate of return. This is internal. Now look at this. If you're, yeah, till here you're getting a positive NPV. Yeah, and beyond, no. Yeah, this is 0. Okay, this is the, there's no NPV to be calculated here at the end of the first year. Okay, this is 7561, and this is 3649, and this is 550. Okay, and the afterwards it goes to negative. I think you are a bit blank. Okay, let me just show you the table. On that day I could not show you.